Alright, welcome back guys. Alright, so now in this video, I figured out the best passive way to cool a thermoelectric generator with not needing to power it to cool itself. So I just took CPU cooler, disassembled it, and it was a lot of work to get all the fins off. So now it's just the heat pipes going up to the flame, in which the flame is heating up that group of heat pipes directly to the CPU, or I mean to the thermoelectric generator. I'm still using the cheap Amazon ones. So this is the output, and the cold side is just a standard CPU cooler. I can probably tip this a little bit to get in there, but it's basically just tap water. Oop! Alright, let me at least get this motor off here. But anyway, so it's basically just tap water, and the CPU cooler is just submerged in the tap water. So all the heat is just being dumped into the tap water. And it's pretty cold. I mean, I just straight out of the faucet on cold. So it's probably around 60 degrees or so. So this is the best way to get passive power. And you get all the power out of the thermoelectric generator this way. So it's able to run a good sized motor like this all on its own. So I'll show you this motor running. It sags the voltage down a lot, but it's able to do it. You can see the motor is running. And then we got a 5 volt. This is a 12 volt motor. So 12 to 24. So it's able to run that, just barely. But then also we have a 5 volt fan. And it's able to run this with ease. And it's actually blowing some decent air. So it's able to run that with ease. You can probably hear the air, but and that's just passive heating and passive cooling. So it's keeping up with the 5 volt fan. It's not quite at 5, but the output voltage on the tag is not even 4, or just barely 4. So it doesn't sag too dramatically with that 5 volt fan. This fan is doesn't clarify how many amps, unfortunately. Nope. Dang. I'm sure it's not much. But you can see the power, or the voltage is climbing after running that fan. And that temperature difference is being pretty constant, other than the heat pipes are. That's why the increase in voltage is because the heat is still building up in the pipes. So you can see the voltage is still increasing, and all that heat is being transferred into the water, and it's just being pumped from the top to the bottom. So it's able to keep a good temperature difference between the two plates. And the nice thing with heat pipes, it evenly distributes the heat. So the temperature is pretty even across the plate. But this is a really good passive generating concept. Instead of using an alcohol burner, and I could get this going probably a lot more, but that's all the flame is right now, and it's not really burning. I need to get this higher or this lower so I can get more towards the hotter part of the flame. But now if I use a hotter flame, I could get way more out of this, because we're probably not running. I can't read I can't read this accurately because it's reflective. Unfortunately, I'd have to get my little scope out that goes into the top here and then touch that. But it is probably around 200. That's it. All right, see you later.